All right, guys, we're going to be going over some problems from the 4-7 solving polynomial equation sheet. The key to this whole worksheet is a strong understanding of factoring. All these problems involve factoring in one way or another. So looking at number 9, the very first thing that I see is we have t squared, right? A lot of these problems are going to have some exponent power 2, 3, 4, something like that. And that really leads me to believe that factoring is going to be the way to do this. So with factoring, you need to set it up in standard form. You need something equals 0. So you want one side to be 0, and you want the whole polynomial to be on the left side, or this could be switched around. The 0 could be on the left, and the polynomial could be on the right. As long as one side is 0 and the other side is your polynomial, you're good to go. So for our first one, I want to go ahead and move this negative 4t and move it over to the other side. So essentially, I'm going to be adding 4t, right? I'm going to be doing it here. There's no like term there, so the left side of my equation just becomes this. All right. Now we've got it in standard form. We can kind of get down to factoring. There's a few ways of factoring. This right here is a binomial. There's two terms. I can see right off that both terms have a t in them. So anytime all of your terms have an instance of the variable in it, you want to factor out the variable. So I'm going to factor out t. It's going to leave me with another t here, right? Because t times t is t squared. And when I factor a t from that, I'm just going to be left with 4. And well, this is factored. As soon as you got rid of all of your exponents, you've got it factored. Now you're going to go ahead and split this up using your zero product property into two equations. The first one is real easy. It's just going to be t equals 0. That's a solution. It's one of my solutions. And then the other one, t plus 4 equals 0. Quick solving this will give us our second solution. T is equal to negative 4. So that one was not too bad. All we had to do is factor by what's called a greatest common. So what I'm doing here is I'm factoring by a greatest common factor, or a GCF, to get my proper factoring. Okay. Next one's going to be a little bit trickier. Looking at number 13. Here we have a few more terms. I guess one more term than the last time. Again, I want to make one side 0. I generally like to have the coefficient in front of my highest power to be positive. So if I move this over to this side, it will make it negative, and then I got to do a little extra work to change the sign. So instead, I'm going to move everything else over to the right side. So I'm going to subtract p, and I'm going to subtract 1. So subtracting p and subtracting 1, that's what we end up with, right? We end up with 0 on this side. Okay. Now it is in standard form. This is a trinomial. There's 3 terms. The coefficient for our middle term is 1, even though there was no number there. And this, we're going to have to use our trinomial factoring. You may have learned many different ways for doing this, but the end is the same. I'm going to try to factor it into 2 binomials multiplied together that are equivalent to that one. Okay, so on top of my diamond problem, I do a times c, 6 times negative 1. And on the bottom, I put the b term, negative 1. And I look for 2 numbers that multiply to the top, add to the bottom. Multiply to negative 6, add to negative 1. So if I'm multiplying to be a negative, I need a negative number and a positive number. And since I know they're going to add to be negative, the bigger number is going to be negative. Answer to this one is negative 3 and positive 2. These will multiply to give me negative 6. They'll add to be negative 2. Okay, we're close here. What that is doing is allowing us to split up that middle term for us to factor. So that splits up the middle term here into negative 3p and 2p. I'm going to do it this way using a factoring box. Again, there are other ways to factor, whatever your preferred factoring method is. This is one way to do it. And now I need to look for the greatest common factor in each row and each column. And these right here will be my factored form of this polynomial. So I'll just start here, this column, 6p squared and 2p. I have a GCF of 2p. It's right here. These are GCF. And I'm going to go here. These have a GCF of 3p. And you can check to see if you're getting the things right on the outside, because if you multiply them, you need to get what's on the inside of the box. So 3p times 2p, that gives you this, 6p squared. Okay. 2p times 1 is going to give me 2p. 3p times negative 1 is going to give me negative 3p. And I want to make sure that does work here as well. Negative 1 times 1, yeah. All right, so I know this is my factoring. 3p plus 1 and 2p minus 1. Okay. And that is, of course, equal to 0. So we can use our zero product property to go ahead and finish this off and get our final solution. So 3p plus 1 equals 0. And then solving these two will give us our solution. So 3p is going to equal negative 1 when we subtract that 1 on both sides. Divide by 3. I get negative 1/3 for my first solution. And adding 1 to both sides. And then dividing by 2, I get 1/2 for my second solution. So there we go, 2 solutions for that one. We could go ahead and plug them back in and make sure they work. I hope they do. All right, and number 21, again, just to give a little bit of a different flavor. This one has a higher power, exponent of 3. So that's going to change things a little bit from what we've done in the past. But I still want to get it in standard form. I'm going to move this over to the other side. So I'm going to add 12x squared to move it over to the other side. Okay. So I end up with x to the third plus 12x squared plus 36x equals 0. Now it's in standard form. We can start factoring it. Similar to problem number 1, thing I notice here is we have x's on every single term, so I can factor an x out. So leave me with x squared, 12x, 36. All right. This one, the factoring is going to be a little bit easier. So I've factored out this one right here. I have one factor for my polynomial, but this inside here needs to factor further. This I can use my trinomial factoring like I did in the previous problem, though it is a little bit easier. But this factor right here tells me I already have one of my solutions. One of my solutions is x equals 0. Right? Because this is already one of my factors. So that's one of my solutions. Because my power was 3 for my original equation, I'm actually going to have 3 solutions for this one. This should give me 2 more when I factor it. Okay? So going through this process, I get 1 times 36 and 12. So 2 numbers that multiply to be 36 and add to be 12. And it is going to be 6 and 6. Again, this would be splitting up the middle term. I'm not going to go through this whole process again. If we need more lessons on factoring, I will we'll just reteach this. But this is going to factor as x plus 6 times x plus 6. Again, I don't need to do the whole factoring box because my leading coefficient here is 1. I can actually go a little bit shorter than the previous problem. Now, we've already got this solution, x equals 0. And this is actually, these are going to give me the same solution, right? They're both going to give me this equation, which gives me a solution of x equals -6. So I said there were 3 solutions, but turns out because we had the same factor here, we call this one a double root because 2 of our factors ended up giving us the same solution. Technically, we have 3. We have this solution here, and then we actually got that solution twice. All right, last one I'm going to go through. This one kind of looks easy because it looks like it's already factored, but doesn't equal 0. We can't solve this right now. It has to be equal 0, otherwise we can't use the factoring method. So turns out we're going to have to just multiply this out, move this over, and refactor. So now I'm going to be doing my FOIL. You could do a box multiplication or whatever method of multiplying you really want to. So this is going to be x times x times minus 3, minus 2 times x, and minus 2 times minus 3, positive 6. Okay, combine like terms here. And I'll go ahead and subtract this 2 here just to save 1 extra step, so plus 4. All right, now again, this is a trinomial. There's 3 terms. Not all terms have an x. This one doesn't have an x, so I'm going straight into factoring. 1 times 4, negative 5. I need 2 numbers that multiply to 4 and add to negative 5. This is a little tricky because I'm multiplying and getting a positive, but I'm adding and getting a negative. So that actually tells me I need 2 negative numbers. 2 negatives will multiply to be a positive, but when I add them together, I'll get the negative. So negative 1 and negative 4 are my solutions. Now again, I don't have to use the factoring box. I could go ahead and, I know this is negative 1x and negative 4x. I could fill out my factoring box now and go that whole way, but shortcut, x minus 1, x minus 4. I'm able to take this shortcut because this is a 1. If that's a 2, a 3, a 4, any number other than 1, I got to do something else to factor this. Okay, and then finish it off. 0 product property, write our 2 equations, and I get x equals 1, x equals 2 solutions. Cool, hopefully that was helpful, and see you in the next video.